Hello there, beautiful internet and you super creatures of the beyond. We're gonna make a small addendum to our filters because the last time I was through the filters jungle, I had a small issue of not understanding how to use the what's it called? Component transfer, not composite, component, yeah. So, my problem was that when I was creating the component transfer, I could not understand how to use table and discrete. And that's because they don't work on one value. If you click on them, you see it says values plural, and the same happens here. So these two seem to work on singular colors, while these two have a different purpose. And we're gonna start with discrete. And for example, if I type here, so the maximum value is 1. That's the threshold. So if I'm gonna start with 0.1, nothing happens. Because right now, it's looking for the red. And there is no red in here. Okay, let's make a red. Now, it is important to understand how this works. The values, which I'm typing over here, start from the base and go to the secondary handle. And depending on where you start to position your gradient, you should understand, like if I'm gonna position the gradient from the right to the left, then the values will start from the right, obviously. So always look for the square. So right now, since we have no red, we're gonna set a red over here. And on this other side, well, this is something that I learned the hard way. Initially, I was doing things like this. So I said, oh, this is going from a bright red to a dark red. So if I would type a 1 here, and then type a 0.5, then type, oh, of course I have to apply the filter. A 0.5, then type a 0.3, then type a 0.9, then type a 0.7. You see, it's not regulating the colors correctly. And this is because all of this is red. This is dark red, obviously, but it's looking at the whole spectrum of the red. So in order to propagate the correct values here, the secondary color must be something different. I'm gonna just take a darker color, in this case a dark gray. And now, if I'm gonna type, let's say, 0.1, then 0.5, then 0.7, 0.9, 0.1 again, 0.2, 0.6, and so on and so forth. Although you have to keep in mind that there is a certain wide it calculates. I'm not entirely sure why. But these sections here have a specific wide. So if I'm gonna go, and they're always pushing, you know? So if I'm gonna go 0.2 again, see? It's placing the 0.2, then it's 0.6, then it's 0.1 over here, and so on and so forth. So yeah, it is a bit tricky. You can also put values like this to kind of push things on the right side. As I said, it depends on how you position your gradient. Okay, so this is basically creating for us a monochromatic gradient that goes from the light to the dark. So if I would go, let's create a very simple idea, 1.2, 0.3, 0.4, 0.5, 0.6, so on and so forth. As you can see, it's really, really nice. And the maximum value, which would be 0, would be here. And you can also end up in a 1 to go to the full gradient. As you see, these are quite blocky. And the way this acts is sort of like a graph like this. So if we're going to start at 0, then we're going to start at -1, then at at point 1, at point 2, at point 3, point 4, and so on, blah 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 blah. And maybe I should disable this, make it like so. So here is the first step, the 0 step. The second one is the point 1 step, point 2, bam 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 bam. So this is how it goes, all the way to the right. Obviously the colors are being shifted to the right. So it's a bit difficult to interpret. The one way to kind of reverse this thing to be in line with this would be if we select this, and where is my color? And if you see, my gradient didn't change. I didn't add anything in the gradient. This is all purely through the filter. You can apply this thing through the gradient as well, but obviously you would have to put the offset specifically here. Now this one has a very fixed offset, and I don't know which one it is, but whatever. It's doing its own thing. So one way to put them in line is to just reverse the gradient and bam, you see? 0.1, pam 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 pam. Easy peasy. Good. Now, this is the first, the discrete value. And of course, if I try to put 2 or 3 or something like that, you see the value doesn't change because maximum is 1. Good, 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 good. Now, let's duplicate this. And now, let's go to our table lookup. Now, table lookup works a bit different. And as you can see, it still maintains the colors here. And that's because we did a basic gradient. If I remove them and I type 0.5, 0.2, 0.9, 0.1, 0.7, 0.3, 0.6, you see it creates these values that are being pushed around, and it identifies where the red is versus where the dark color that has no red in it is, and it kind of overlaps them, and it creates this interesting and unique gradient. And as you can see again, we haven't changed anything to the gradient. Maybe I should have made a secondary filter because this applies to the first one as well. So let's do that really quick and apply the component. Bam. Apply the filter. And for this one, I'm gonna select this, put it here, and this we're going back to our discrete. Whatever, we can leave it like that as well, just to see how. So you can see this is gradual, while this one is blocky. And to exemplify how this one works in steps, but this one works something like, oops, no, undo this. Works something like a graph. So Obviously we start from, let's consider that this is 0.5. Well, actually let's start with a 0, so we know where we start. Again, the colors are being pushed to the left in this case, but anyway, so we start with 0, then we go to 0.5, then we go to 0.2, then to 0.9, then to 0.1, to 0.7, to 0.3, and then to 0.6, like so. So as you can see, it's basically following the high points and the low points of this graph, and it creates this kind of wavy gradient, but again, it's maintaining the same offset. So this could be super useful in situations where you make a normal gradient on an irregulated shape, and let's say you don't have only red and blue, red and black, or dark gray in this case, but you have something like red and green. So if I'm applying green on the last part, oops, didn't select the color wheel. My mistake. Let me go and select the green. So we're gonna light this up. We're gonna look for the green, and voila, you see? And I don't need to change anything, like, because if you would make this normally, you would have to come back and reapply the whole gradient combo here. Like in this case, if I would add another node, I would have to remove it and then change it to mix the color between the red and the green. But this one does it on the fly. And it's also cool because, as I said, it applies to irregulated shapes as well, so you can apply it to any type of gradient you like. And if we want to go over here as well, we just need to change this, and let's light it up. Let's go to a blue. You see? And this one automatically tries to shift the colors between those. If I'm trying to go to, well, yellow is too close to red. Green again pushes things like this. But as you can see, the more I approach red, the less the steps are becoming prominent between each other. And the same happens here, I'll show in a moment. So trying to go into the opposite spectrum creates more steps. Obviously, the sharper the color is, because right now we're applying some saturation to it, you see? But if I apply more saturation, I mean, this is less, this is more. We are defining the colors better, which is really nice. So let's keep it on a blue. If I move it on a red, you see, this is what happens. It's nice, it only creates a 2 value because it's trying to go back to red. But the more different from red is, the more steps we get. So let's get rid of blue. And let's try to apply the same principle here. So if I approach it like this, if I go into the red, you see it creates a normal 2 value gradient. If I push it onto the opposite spectrum, and the more saturation I give it, so this is low saturation, high saturation, then we get different different values. I really like how it's going. So very, very, very powerful. And it's really cool because if you want to, for example, change it from discrete to table, you just do it on the fly. You don't lose the values here, so you don't have to reintroduce them manually, which is fantastic. And even if you go to a linear, although the linear only applies in this case to the red, so it does not affect the blue, so you would have to go into the linear or into the gamma, whatever you choose, and modify them separately. So as you can see, this does these things. The offset, these are also graphs, the linear and the gamma, but they are more, gamma is sort of like a curve that goes like this from 0 to 100. Just remove this. But it can also go into the negative, and it can go like this, but keep in mind that if you go past 100%, it will just go like this. It can't go past 100%, so it will keep its value somewhere there. And in the case of linear, it's just a line. Simple like this, or it can go into the negative as well. So in the case of the gamma, if you push the offset, it pushes the line, sorry, the curve higher on the graph. So the graph would look something like this. So you would have the offset on this side, and this is how your line is developing, your curve. So if you would have 0 here, the more you push the offset from 0, the higher it goes. And in the case of the line, which is the linear component transfer, it's our interceptor that pushes the line up, and the slope is its inclination. That's kind of the theory that I've been reading about. It's quite interesting, it's all mathematical, but it can create some superb things here. So going back to our linear and gamma, as we can see, we can combine them. It's quite nice, but we have to know which things we have to tackle. And even if I would introduce new elements, where is my fill? So if I would introduce new elements in here, let's say I introduce a new color. Let's go into the greens. No. Well, actually, yeah. Something like this. Now I have, well, maybe we should make this one blue. So now I can play with the blue in this case and control exactly how much I want of the blue. Of course, this one is very sensitive, so okay. And then if we go into the red, we can also push how much we want into the red. Of course, depending on how many nodes you have here, the distance between them dictates how much you can push these values, you know. So if I'm gonna push this, it's gonna try to push as much. It's raising the. You can think of this. The interceptor is how much light it lets in, and the slope, the intensity of the light. So with this, I'm letting a lot of light in, like opening the window and letting more, or a cover of the window. And this one is the intensity of the light that's coming through the window, or the sun, whatever. And the amplitude kind of works the same. But this one, as you can see, it's working on the opposite spectrum, because this is where our blue is. So this is dictating how much we're opening the window, and this is how intense the light is. But then you also have the offset that kind of fine-tunes the global values. So I'm going to reduce them both. Let's put them at 0 and 1, or maybe not 0, but be a 1. Okay, and now if we want to focus on the green, we go on the green, and we can also do a linear, for example. And of course, it's also affecting the other two graphs, because the color is blending in between them. But we can also try table lookup, for example. Let's try actually discrete value. Let's see what happens. 0.5, 0.9, 0.6. It's already becoming complicated, but it's quite interesting that we can do it like this. So now let's try to go into a table lookup. This happens. So we're pushing values in many ways, and these combos are very powerful. And of course, the alpha, well, for the alpha, you would just use a linear, I suppose. But if you want to do a discrete, let's try. I don't know how it's gonna work out. So let's go with a +2, +5, +7, +3. Point, sorry, not plus. I guess it's not working as intended. It's just taking the last value. I thought it would go into steps. That would have been interesting to have a gradient. Well, technically you can do it, but I'm not sure you can do it like this. Let's see if I do table lookup. No. So I guess the alpha applies globally for the component. It doesn't apply like you would do with the alpha here. You see, I could reduce the alpha like so if I want to. And it only applies to one node, not to all three of them. So I guess this one is a limitation in this case. It doesn't work the same. Let's try 0 and 1. Yeah, it just takes the last value. That's kind of sad. But then again, you don't really need all that much because you can still control the values from here. So again, a lot of fine-tuning when it comes to control. So the same happens with the discrete, right? Yeah, and the table lookup. Yeah, and with the linear, you're just, yeah, it's global. Well, it is what it is, but at least it works, which is really, really awesome. And of course, you can do a lot of combinations here. Add other filters. I can, for example, blur it if I want to. See? Super nice. And this is very non-destructive. Well, obviously, in Inkscape, the majority of the actions you take are non-destructive, unless you go with the when you decompose a clone. I mean, when you detach a clone, or you combine shapes. Paths. Or when you're doing life path effects, and then you flatten the life path effects. That's the only time you are destructive. But here, everything is non-destructive, which is mega awesome. And what else can we do here? Unfortunately, this one isn't applied, and I really wish it was, because these ones just don't do anything. It's really funky. Maybe if I applied the gradient? Nah. Nothing. Absolutely nothing. Sad. They should probably put like an information over them to say it's implemented or not. And I really wish I could make the blend work, because for the blend, if it would have worked with the background images, technically, so for example, if I would add another, well, let's put a rectangle. And let's make it, I don't know, dark red. Put it all the way behind. So what would have had to happen is if I would have made this blend onto the background image, it should have changed this blending mode. But again, as I said, it doesn't work unless I apply directly here, which is really, really sad, because it would be so amazing. Technically, you can kind of leave it like so, and it will go a bit into, well, you can induce a bit of opacity, or maybe could combine it with composite between this and this. No, it would. It wouldn't work. It wouldn't work because it would have still to be the background image. That's sad. But yeah, you can do some really cool things. Okay, I'm gonna leave it at this. I really hope you guys enjoy the mastery of the filters and you do your own awesome experiments. And I'll catch you all in the next episode. See ya. Bye 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 bye.